Children, now let us pass on to the next section from set theory. And this is a very important section. This section is Venn diagram. Now, what is Venn diagram all about? See, Venn diagram is a pictorial representation of sets. You picturize sets through diagrams. So, Venn is the name of a mathematician, and the name given Venn diagram. So, it is nothing but a pictorial representation of sets. In this, what we do is, in this, we represent sets A, B, C by means of circles. So, these will be representations for sets. See, there is a set which contains all the sets which are mentioned. Such a set is called universal set, and a universal set will be represented by a rectangle. So, what is a rectangle representing for? Rectangle means the set which contains all the sets under consideration. That is called universal set. So, a universal set will be only one which will contain all the sets. It will be represented by means of a rectangle, and all the other sets A, B, C will be represented by circles. Right? Now, how do you represent this? What is the need for representation? You will get a little more clarity about the topic which you are studying. Suppose I take a case like this. I take a universal set, and in that, if I take two sets A and B, like this. See, this is one representation of the two sets. This is universal set. What do you say mean from this? So it means that A and B, the two sets are intersecting, which means there is a region which is common to the two. Or in other words, from here you can interpret that there are some elements which are in A as well as in B. This is what you mean by. So this is the use of representing figures by means of Venn diagram. Now suppose I say a case like this. I take a universal set U, right? And I take a set and take another set inside the first one. So if I say this is set A and this is set B, it is very clear that set B is completely inside set A, which means B is contained in A. You can say now B is a subset of A. So B is a subset of A because B is completely contained in A. So you can say this is a subset, an excellent definition of a subset. So B is a subset of A. Okay, now see the next one. I take universal set. Now I take a set A. I take another set B, A and B. See, no connection. No connection. Which means the elements of A and B are completely different. Such type of sets are called disjoint sets. Disjoint sets. This is an example where there are some elements common to A and B. In this case, the set B is completely contained in set A. In this case, they have no connection, or in other words, we say the two sets are disjoint. So this representation, or this diagram is called Venn diagram. Okay. Now let us enter into a next important section, and we'll see the application of Venn diagram also into it. A very important section called operations on sets. So you can operate the sets. You can take the sets A and B and you can operate. Just like number system, like addition, subtraction, multiplication, division in number system, there are similar operations in sets also. You can operate sets. The first operation that you study here is called union of two sets. The symbol for union, the operator is U. Just like addition, this is a symbol which you are going to see in this. this is an operator and this stands for union of the sets, say A and B. Now, what is union? Suppose I take two sets A and B and let them be non-empty sets. What do you mean by saying non-empty? There are elements in both the sets. They are not null sets. Okay, so let me take two sets A and B. Suppose I say if an element X belongs to A union B. See, this is how you write union of two sets. What does that imply? This implies and implied by X will be an element of A or X will be an element of B. It means that if an element X belongs to A union B, what do you mean by saying A union B? A operated with B and the operator is union. So when you operate A and B using this operator union, what does that mean? It means that if an element X belongs to A union B, that element will be either in A or in B. Either case must happen. Either it should be in A or in B. It can be in both also, no problem. So this is what you mean by saying X belongs to A union B. Say for example, if I say A set contains 1, 2, 3 and B set contains say 2, 3, 4. See, A union B is 1, 2, 3 and 4. And now you come to the definition and connect this with the definition. If an element X belongs to A union B, then that element will be either in A or that element will be in B. 1 is in A. 2 is in A. Also it is in B, no problem. It should be either in A or B. It can be in both, no problem. 3 is in A. It is also in B, no problem. 4 is in B. So any element that belongs to A union B will be either an element of A or an element of B. This is what you mean by saying union of two sets. Hope this point is clear. Now I'll show you how to represent union of two sets as Venn diagram, in the Venn diagram form. Suppose I say two sets are like this, interconnected, are there intersecting sets A and B, right? This is universal set. How do you represent A union B for this case? See, A union B for this one will be an element in A union B will be either in A or in B. So this whole region represents A union B. This is A union B. Suppose it is like this. Suppose the sets are in this manner. Universal set. You take this case A and B is completely contained in A. So what is A union B for this? You will shade the whole of B. You'll shade the whole of A. That's enough. This is A union B. This is A union B when B is a subset of A. Suppose you take the case two disjoint sets. Suppose I say two disjoint sets A. This is set B, A, B. What is A union B for two disjoint sets? You will say the elements will be either in A or in B. So which means you just shade A as well as B. So all these are the representation for A union B in the Venn diagram form. So what do you mean by saying A union B? When you say an element X belongs to A union B, it means that the element will be either in A or in B or both, no problem. Now, let us go for the next operation. The second operation, we say intersection of two sets. Intersection. The symbol for intersection is U inverted. U inverted. So here if I take two sets A and B, two non-empty sets A and B, and if I want the intersection of the two sets, we write like this. This means A intersection B. What do you mean by saying A intersection B? It means that if an element X belongs to A intersection B, if an element X belongs to A intersection B, it implies an implied by, in the reverse order also you can see, implies and implied by that element X will be in A and that element X will be in B also. So now you compare it with the previous operation. When you say union, it will be either in A or in B. It's not necessary it should be in both. Here, when you say X belongs to A intersection B, it means that that element must be there in both. This is what you mean by saying X belongs to A intersection B. Now let us see the pictorial representation of the sets. Let me just take all the three cases once again. This is A, this is B, union. The second representation, when one is a subset of the other, say this is A, this is B, universal set. The third case, disjoint sets A and B. So how do you represent, or which region represents A intersection B? See, for the first case, what do you mean by saying A intersection B? It means the elements which are there in A as well as in B. It is this region. This is A intersection B. How do you represent A intersection B for this case? Which region represents A intersection B? It is this region, the set B. And what about the last case? There is no element common to A and B, which means here there is no region representing A intersection B. Or in other words, here A intersection B is actually a null set. Now we have already said that these two sets are disjoint. So what is the definition of a disjoint set? It is nothing but A intersection B will be a null set. If two sets are disjoint, their intersection will be a null set. So this is how you represent the region for A intersection B. So this is the second important operation in set theory. The third one, let us come to the third one. The third is difference of two sets. Difference of two sets. So let me take two sets A and B. The difference of two sets is written as A minus B. What do you mean by saying A minus B? Suppose I say an element X belongs to A minus B. It implies and implied by that element will be in A and that element X will not be in B. So this is the definition of A minus B. An element in A but not in B. This is A minus B. So the symbol for difference is minus. You just put the same symbol which you use in number theory. So A minus B. It means elements that are in A but not in B. I'll take two types of examples. Suppose I say set A as 1, 2, 3 and B set as say 2, 3, 4. What is A minus B? It means element that is in A only. A only, so which is 1, which is not in B. So A only means set 1. Okay, now how do you represent this in the Venn diagram form? Let us take all the three cases once again. So I take one set A, the other set B, this is A, this is B, universal set. Let me take the next case where this is A and B is contained in A. And the third set where A and B are disjoint. So how do you represent A minus B, or what is the region which represents A minus B? When you say A minus B, elements that are in A only, this is A minus B. This region is A minus B. Now here, what do you mean by saying elements that are in A but not in B? So the region outside the circle. This is A minus B. What about here? The region that is in A alone. So this is A, which is not in B. So this is A minus B. You can call this as A minus B also. right? So what is the need for pictorial representation? You can interpret lot many things other than what we are seeing right now, other than what we are discussing now. When I say like this, what is the other interpretation? You know that this is set A. This is also called A minus B. So here A minus B is equal to A. But when B, A and B are disjoint. So these are some interpretations that you can take from this representation, this diagram. I hope this point is clear to everyone. So this is the third important operation of sets. Let us come to one more operation. Let us come to one more operation. The fourth operation, we call it as a complement of a set. Complement of a set. Now, suppose you take a set A. The complement of set A is denoted as A dash. Or there are other symbols also, you can write A bar. Complement of a set means, this is the definition. When you say a complement, it means all those elements that are there in the universal set but not in A. In simple terms, you say complement means elements that are not in that particular set. So complement of set A means elements which are not in A. So where will they be? They will be there in the universal set. So you define a complement as universal set minus set A. So here I am just taking one set in the universal set. This is A. So this is A. The region inside is A. So A complement will be the region outside. This is a complement. And this is defined as complement of set A. I hope these operations are clear. So let us see the operations once again. Let us see the operations once again. I said there are major operations. One is union of a set, A union B. The second one is intersection of two sets, A intersection B. Third one is difference between two sets, A minus B. And the last one is a complement of a set. So I'm just discussing those major terms that you will come across in this particular chapter. So these are the different operations and their definition and their Venn diagrammatic representation. I hope this much is clear to you. Okay, right. Now let us go to questions from this. Okay, now see children. It's given A is equal to set 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 7, 8. C is equal to set 7, 8, 9, 10, 11. And D is equal to set 10, 11, 12, 13, 14. Let us see these questions. So you are going to operate. The first one is A union B. What do you mean by saying A union B? An element that belongs to A union B should be either in A or in B. So how do you say the elements? 1, 2, 4, 5, then 6, 7, 8. You don't need to repeat an element twice. And now you just see, you take any element, that element will be either in A or in B. So this is A union B. Let us see A union C. A with C. So it's 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. So, and you take any element, that element will be either in A or in B. So this is A union C. Let us see B union C. B union C. So it's 4, 5, 6, 7, 8, 9, 10, 11, isn't it? You take any element that belongs to B union C, that element will be either in B or in C. So this is B union C. I hope this is okay, right? This is okay. Now let us see for the next case, what is B union D? That is B union D. Just see this one, B union D. What is B union D? So B union D is a set B with D. So 4, 5, 6, 7, 8. Then the elements of D, 10, 11, 12, 13, 14. This is B union D. Now A union B union C. So A, B and C taken together. So it will be 1, 2, 3, 4, 5. Now the elements of B, 4, 5 has already been taken. 6, 7, 8. Go to the C, 7, 8 already taken. So 9, 10, 11. This is A union B union C. Now what about this one? It's A intersection B union C. So first you take B union C and then with A. Okay, now what is B union C? See, B union C, I'm just writing it here. Let us leave A as it is. 1, 2, 3, 4 and 5. Union. Sorry, not union, it is intersection. B with C. B union C. What is B union C? B union C will be 4, 5, 6, 7, 8. Then here 7, 8 has already been taken. 9, 10, 11. And now you need the intersection of the two sets. What do you mean by saying intersection of two sets? The elements that are in the first set and the second set. Both. The elements that are common to both. So the answer is 4 and 5. This is intersection. I hope this is clear. Now let us come to the next one. What about B minus C? What do you mean by saying B minus C? B minus C means elements that are in B only. In other words, elements that are in B but not in C. So you just see the elements of B and C. So what are the elements that are in B alone? It is 4, 5 and 6. What about C minus D? What do you mean by saying C minus D? Elements that are in C only. Means elements in C but not in D. So just see the elements of C and D. C and D. So the answer is 7, 8 and 9. Elements that are in C and D. C only. This is C minus D. I hope this question is clear to you. So this example will give you an idea about the operations union, intersection and difference. Okay, let us pass to the next question. Just see this question. U stands for universal set. Set contains 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to set 1, 2, 3, 4. B is equal to set 2, 4, 6, 8. C is equal to set 3, 4, 5, 6. Now, let us find out this. What do you mean by saying A slash? It means A complement. What do you mean by saying A complement? Elements which are not in A. Then where will they be? Those elements should be in the universal set. So, elements that are not in A but in the universal set. So, isn't it 5, 6, 7, 8 and 9? This is A complement. What about B complement? B complement means elements that are not in B, but they will be in the universal set. Or in other words, the elements that are in the universal set, but not in B. So 1, 2 is not there, 3, 4 need not be taken. So 5, 6 not taken, 7, 8 not taken, 9. So 1, 3, 5, 7 and 9 are the elements in B complement. Now what about A intersection C, the whole complement? First you find out A intersection C and then you take the complement of it. Let us find out what is A intersection C. Let us find out what is A intersection C. A intersection C means the elements which are common to A and C. So 3, 4, 3, 4. So set 3, 4. Now let us define what is A intersection C complement. Means elements that are in the universal set but not in A intersection C. Which means 1, 2 not taken, 3 not 2 taken, 3 not taken, 4 not taken. So 5, 6, 7, 8 and 9. What about A union B, the whole complement? So first you find out A union B. First you find out A union B. What is A union B? A union B means 1, 2, 3, 4 1, 2, 3, 4, then 6 and 8. Now you take the complement of it. What do you mean by saying complement of it? Elements that are in the universal set but not in A union B. So 1 is not to be taken, 2 cannot be taken, 3 cannot be taken, 4 cannot be taken, 5 is there, 6 no, 7 yes, 8 no, 9 yes, 5, 7, 9. What about a complement? See, here you don't need to take any case here. You know a set, you take the complement and again the complement, you will get set A back. What about B minus C? The whole complement. So first you find out B minus C. What is B minus C? B minus C means elements that are in B but not in C. So elements that are in B but not in C. 2, right? 4 cannot be taken, 4 is there in the C, 6 cannot be taken, 8 is taken. So 2 and 8 belongs to B minus C. So what will be B minus C complement? Elements that belong to the universal set but not in B minus C. So 1, 2 already in B minus C, 3, 4, 5, 6, 7, 8 not taken, 9. This is B minus C complement. I hope this question is clear. So with this, you will get an idea about the different operations, mainly union, intersection, difference and complement. I hope this section is clear to you. My children, now we'll have to work out more of these questions. Okay, right. Thank you.